Ladies and gentlemen, dear colleagues, at the beginning of the lecture, I would like to thank the organizers for inviting me to present the DOJAM project at this important conference. Due to the fact of regional crisis and growing illicit trafficking, the need of a large-scale inventory of archaeological material in Jordanian museums became strikingly aware. Therefore, a collaborative project between the German Protestant Institute of Archaeology in the Holy Land, GPIA, and the Department of Antiquities of Jordan, DOA, was established in January 2017. It is financed by the German Gerda Henkel Foundation, whose main objective is to support the historical humanities, archaeology, the history of art and other disciplines with a historical component. The project is entitled DOJAM, Documentation of Objects in Jordanian Archaeological Museums. The aim of this four-year project is the protection and management of archaeological objects stored or displayed in DOA museums, which is compatible with the 2014 to 2018 DOA strategy. In February 2017, a memorandum of understanding was signed by Dr. Munzir Jamhawi for the DOA and Dr. Katharina Schmidt as the representative of the German Protestant Institute on behalf of Professor Dieter Viehweger, the Director General of the GPIA and head of the project for the German team. I have been designated as the local project manager on behalf of the GPIA. The objectives of the project are as follows: developing a database for museum management and scientific research for all archaeological museums in Jordan, registration and documentation of archaeological finds, photographing of each object and 3D digitizing of selected objects, conservation and/or cleaning of endangered archaeological finds, management of storage facilities and equipment of conservation lab, and the training for DOA staff. The Jordan Archaeological Museum on the Amman Citadel will act as a pilot model. It was the National Museum from 1951 until the Jordan Museum was opened in 2013. It is particularly suitable for a pilot project because it covers a large collection of objects. There are approximately 1,500 finds on display and 7,000 to 8,000 in the stores. Furthermore, the collection encompasses a diversity of archaeological objects such as pottery vessels, decorated stone objects, flint tools, glass vessels, and metal finds. The dating of the objects covers a time span from the Paleolithic to Ottoman period. The main task of the project is the development of a museum database and the registration of the archaeological finds. From past experience with other databases, two main focus points have been determined for the development of the database. The first focus point is the long-term maintainability, counting in decades. The second focus point is providing high usability. The main user group working with the database on a regular basis will not have either a scientific nor a technical background. Providing a database that has a good technical long-term maintainability is one thing. Another question is if the database is actually used to its full potential. To achieve this, common tasks like inserting an object into the database must be as painless as possible. Here is a screen of the database to get an impression of the overall design. It shows an overview of all data associated with a single object to allow the user to confirm that the data was correctly inserted. In the following slides, an overview will be given of the technologies used to provide long-term maintainability, how the goal of high usability influences the graphical user interface, and how certain usability features were achieved from a technical point of view. To achieve long-term maintainability, only open source and well-established and mature technology have been used. Relying on open source also makes the Department of Antiquities independent of licensing, which means lower and foremost more predictable cost in the long run. Ruby on Rails has been used to build the actual database application. PostgreSQL is used as the database management system. Both can be run on common servers. Debian Stable has been chosen as a very common operating system. Ruby on Rails, often just called Rails, is around since 2005 and received a very good critics for its design and because it allows for high productivity. Nowadays, other similar frameworks are in use, but nevertheless, Rails is still a highly popular framework. As Rails is a web application framework, the database application can be accessed by any modern browser, which brings a lot of flexibility and provides long-term compatibility. While PostgreSQL differs in many ways from the better-known MySQL, it also uses tables to store data, and SQL can be used to query the database. If you have heard of MySQL, but not of PostgreSQL, you must think of a feature-rich variant of MySQL. PostgreSQL has been chosen as it is the best supported database system for Rails. At last, as you might know, Linux is much more used for servers than for desktop PCs. Debian is a very common Linux-based operating system, providing a highly stable platform. Looking at some aspects of usability, an example of a visually highly overloaded database application is shown, which is error-prone and not very inviting to enter any data, let alone dozens of highly specific scientific data. As already stated, the goal of the DOJAM project is to create a database that can and will be used by non-technical and non-scientific staff. Special attention was given to the process of adding a new object to the database, as this is typically the most work-intense aspect when dealing with this type of databases. For this, the entry of a new object has been split into several meaningful steps, starting with general data about the storage location up to more detailed information. The slide shows the form for the step that asks to enter information on the acquisition of the object. Wherever possible, predefined lists have been prepared for the user. This avoids typing errors and enables a clearly defined terminology, which makes querying the database much easier. It eases also the decision-making for the user, which term should be chosen. One interesting feature are the smart lists. For a general object, a list of, for example, all possible production techniques can grow into dozens of entries, which complicates to identify the right choice. The DOJAM database helps the user by starting to ask for more general information about the material and kind of object, and in allowing data entry steps, the possible choices have been reduced to what makes sense in the context of what was chosen before. For example, as it is known that there are no armory made of glass, there is no reason to show armor as a possible choice for a glass-made object. With the presented two example, this approach reduces the possible choices from 36 choices down to 9, respectively 7. A closer look will demonstrate how these smart lists are designated with regard to the technical perspective. Smart lists are made possible by an approach called materialized path. The user starts to choose first the material of the object, second the more specific material type, third the kind of the object, and at last the more specific type. This gives us a sorted list, which is called a path in this context. To show the user only what is relevant to him or her, we associate every path with matching terms, and only those will be presented to the user. It's easy to see that every term might be associated to multiple paths and thus shown to the user for different object kinds. We see here the simple example of the production technique free-blown, which is associated to multiple paths. Let's say the user inserts data for a jug made of glass. He later will be presented with free-blown as a choice for the production technique because free-blown is associated with the corresponding path. This is very close to the actual database design. What we first notice is that we have one single general table of terms where we find all types of terms. This is an approach called single table inheritance and is justified by the fact that all terms are pretty much identical except for their type. We also see that the path in fact only contains slash-separated numbers. Every number references a term ID on the first column. Using the ID instead of the name is the natural way to do from a pure database perspective, and it also helps us against problems when dealing with names that contains slashes. Here we see some example with how free-blown is associated with its corresponding path. While this is very close, what I have just presented here is the English version of the database. However, there's also an Arabic version, and the user can choose which language is more comfortable for him or her. Aside the registration of the archaeological finds in a database, photographing of each object is also included in the workflow. We carried out also 3D laser scanning of highly valued objects in the exhibition of the Jordan Archaeological Museum. The storage of archaeological finds is a big challenge for all the museums and other institutions. This is also true for the Jordan Archaeological Museum. Therefore, we improved the storage facilities there during the last 2.5 years. The storages were renovated and facilitated with new shelves and boxes. We only use material which can be bought in Jordan, since we find it important to give the DOA and the museum the chance to continue with the same or similar equipment in future. Due to the fact that some of the museum objects are in a pure state of preservation, a conservator has also been employed by the project. He restored selected objects, cleaned almost all objects in the exhibition, and assists in setting up preventive measures for future protection of the finds. Another major focus is the provision of training for the DOA staff in all aspects of the documentation process. This is extremely important as once the collaborative project is completed, the process will be applied to all other archaeological museums in Jordan under the responsibility of the DOA and performed by local museum staff. In order to facilitate future training, a Jordanian archaeologist as a team member for the duration of the project who will thus be qualified to act as a trainer for other DOA employees. This will ensure that the project is both successful and sustainable into the long-term future. As we all know, cultural heritage has been increasingly under threat over the past few years, ranging from natural catastrophes, the looting of sites and museums, illicit trafficking, and war. In order to minimize destruction and damage to archaeological finds, risk preparedness is now a priority for the responsible authorities, as well as for the archaeological community in general. Therefore, design and implementation of a risk management plan, which includes action strategies in case of emergency, is one objective of the project. This will be done in cooperation with international institutions and in accordance with international convention and in compliance with all relevant Jordanian laws. However, it must be emphasized that recording archaeological objects in the context of risk preparedness is the most important task and must be completed as soon as possible. Therefore, the second phase of the DOJAM project started in April 2021 and will continue for about 2 years. During this phase, a server will be established at the DOA, and all the archaeological museums in Jordan, as well as the DOA main storage for archaeological objects, will be linked to the DOJAM database, and the collections will be reorganized. Of course, this cannot be finished within 2 years, but as soon as the basis is implemented, each museum can continue the work according to their personnel and logistical capacities. This opens the way for a real collection management in regard to administration and research. Thank you for your attention.